Control contains mainly two types, decisions and loops. Decisions are also about selection, which is the branching of flow based on a decision. And loops are also repetition, which is the looping of flow to allow statements to be repeated. A decision example is like the following, which is very simple temperature decision, if-else statement. If temperature is larger than 90, we display too hot, need to turn on AC. Else if temperature higher than 70. This means the temperature is within the range of 70 and 90. We display normal operating range. Else display too cold, turn on heater. And this is the case when the temperature is lower than 70. And the if statement always ends with the line and. So in these decision statements, we always use logical conditions. The first, most widely used logical condition is not, which is used to perform logical negation on an expression. And another one is and, which is used to perform a logical conjunction on two expressions. Or, used to perform a logical disjunction on two expressions. Here is an interesting example, which shows us the priorities of the logical condition operators. So here we have a equals minus 1, b equals 2, x equals 1, and y equals the character b. And character b is in the range of 33, 34, about that range. And the further characters will take bigger numbers. So we are going to come up with a decision of true or false for the current logical condition, which is a times b larger than 0 and b equal to 2 and x larger than 7, or not y larger than the character d. So the comparisons have higher priority than the logical and or. And the parentheses have the highest priority overall. So here, the first step, we are going to execute the comparisons and the parentheses. So a times b equals minus 1 times 2, which is minus 2. Is it larger than 0? No. So it came to the result false, which is f. And 2 equal to 2. B is 2, right? B is given 2. So 2 equal to 2 is true. So we return true for this statement. And 1 larger than 7, because x is given as 1. This is false. Or not, parenthesis. Character b larger than character d. As I just mentioned, going further with the characters, it associates with bigger number. So this is false. In the next step, we are going to execute the first logical AND, which is f true, false and true, which give us false. And false. Or not false. So not false give us true. So in the next step, we have false and false or true. False and false give us false. In next step, we execute the lowest priority, logical or, f or t. In the end, we get the result t, which is true. So the decisions for this logical, so the result for this logical condition analysis is true. So here are some more introductions of the relational operators. Some we just used, less than, greater than, not. And here is a list of all the operators' priorities. As we can see, the highest priority gives to the parenthesis, and the lowest priority gives to the element wise or. So here, next we talk about the for loops. We just finished talking about the decisions. So here is the for loop. For loop is for repetition, as mentioned. So the typical for loop form is the first line of the for loop is for variable equals expression, and the body of the for loop is command lines, and it always ends with the end line. And an example of for loop is for t equals 1 to 500. That means t will loop from 1 to 500. So the command for this for loop is yt equals sine 2 pi t. So for each of the t value, we calculate a y value, which is sine 2 pi t. So in the end, we will get a y vector regarding t values from 1 to 500. So another flow control, loop control is while loop. Similarly, it has first line while expression, and the body of the loop is commands, and in the end, it has an end line. An example is as the following. We have an initial value for the variable EPS equals 1. While 1 plus EPS larger than 1, we will execute EPS as half of EPS. So each time we cut the EPS into half until 1 plus EPS is no longer larger than 1. We will end this while loop. And in the end, we give EPS equals 2 times EPS as our final EPS value. So there is a break statement which is not shown in the above examples. Break is used to terminate the execution of the loop immediately. So we will talk about, you will have the opportunity to practice using break in your lab exercise. So this is a function example using for loops. In fact, most of the built-in functions or the functions that you are going to generate will somewhat involve loop controls using either for loops or while loops. So in this example is to calculate the factorial of n. Initial value x equals 1. Here it has a mistake. The x equals 1 should be a line, a command line, not in the commented line. So for I equals 1 over n is the input of the function. X equals x times I. So for each I value in this for loop, we get an x value, which is, if you look at the structure of this, first I will be 1, right? And x is 1. So x will be 1 times 1. And then after this command, I will be increased to 2. So x will be given a new value, which is x times I, which is 1 times 2. Now x is the value 2. And then I will, after this command, I will be increased to 3. And x will be 2 times 3. And then in the next loop, x will be 6 times 4. So going on and on, in the end, we get the f out equals x, which is the output of the function, also the factorial of x. We talked about using the loop functions, but in fact, we need to think about efficiency, computing efficiency. To improve computing efficiency, when it's possible, we need to do vectorization. So here is a for loop example, where t loops from 0 to 50 with a step size of 0.02. So inside this for loop body, first line is I equals I plus 1. I will be increased by 1. And yi, which is the ith element in a vector y, will be equal to cosine t. So for each small t changes, we have a new y element added to the vector y. And in fact, this will return a y vector of cosine t, right? Cosine t vector. So we can replace this for loop with the following. First, we generate t as a vector, 0 to 50 with a step size of 0.02. And then we directly do a cosine operation on the t vector, and we can get the y vector easily. So it's pretty straightforward, and it's called vectorization. And whenever possible, vectorization is recommended because it's a way to improve computing efficiency. Another way to improve efficiency is memory pre-allocation. So a bad example is on the left side, where we again have this t vector generated from 0 to 5 with a step size of 0.01. And then we have I as our variable for the for loop. If ti bigger than 1, we give yi, which is the ith element in the y vector, to be 1 over ti, else yi equals 1. So as I increases while running the for loop, the y size will increase again and again and again. But we didn't predefine a space for this y vector because we don't know how long this y vector will be. So we just add elements to the y vector dynamically. And this usually will cause memory allocation workload, which is not necessary if we use the right side solution, which is instead of generating just the t vector, we also generate a y vector with all ones. Y vector is ones of size of t. So we pre-allocate a space for this y vector, and then inside the for loop, we fill each element of the y vector with the calculated value. So this is a way to pre-allocate memory for a variable, and it will avoid fragmentation of the memory. So next, let's talk about nested for loops. Based on the name, we know there is a nest somewhere, right? If you look at the example code here, we have the outer for loop for j equals 2 to n, and the end, we have an end line to end this for loop. And inside this for loop structure, we have another for loop, which is for I equals 1 to j minus 1, and some execution there with commands, and also again, it will end with an end line. So if we look into the steps of carrying out the nested for loops, in loop 1, we have j equals to 2 and I equals to 1. So in the first loop, we will generate two values. The first value is aij, which is a12. After calculation, we get 0.5. Similarly, we get aj. I already runs through its range. We will increase j, the outer for loop, to be 3, so that we can execute a13 and a31. Now in loop 3, since I just looped through 1, it still has a value j minus 1 equals to 2 to be looped through. We now have I equals to 2 and j equals to 3. So in this loop 3, we calculate a23 and a32. Now we finished the inner for loop. We go to loop 4, which is to give the j value to the incremental, which is 4. So now I goes back to value 1, the inner nest. And now in loop 4, we execute a14 and a41. So eventually we will have our 4x4, which is 16 loops executed. Again, pay attention to the order. The inner loop has higher priority in execution. So you need to execute all I variables first before you increment the j variable, which is the outer for loop. So some examples of the while loops. Revisit the while loop structure, while condition. If the condition meets, then the statements will be executed until the condition does not meet anymore. Then we can end the while loop. An example is like the following: x equals to 8, x is given to 8, and while x larger than 0, we will do x equals x minus 3, which is to deduct 3 out of x and display this x. And we can see that once x was subtracted by 3 times, it will be minus 1. And by that time, this while loop will end. And there's another while loop, which keeps the loop going on and on, which is called while 1. And in this case, usually we will set an if condition inside the body of the while loop and use the command break to break out of the while loop. An example is while 1, that means always run this while. If x smaller than 0, break, end. X equals x minus 5. So in the previous example where x was initially given to 8, in the first loop of this while loop, x is 8, so it won't break. It goes to the next line, which is x equals x minus 1, which gave us x equals to 3, right? So then it goes back to the while loop again and see if x is smaller than 0. It's 3, it's not smaller than 0. So the break won't happen, and x will be x minus 5, which is this time negative 2. And this loop ends, and we go to the next loop. Now we see if x is -2, smaller than 0. Now we break. So the next line, x equals x minus 5, will never execute again because we already break out of this while loop. Okay, this is the end of lecture 2. Please write down any questions you might have and bring them to the lab exercise session so that we can discuss together.